today we'll talk a little bit about AWS Cloud Development Kit. I will show you agenda. I will talk a little bit about infrastructure as a code in general, and specifically about CloudFormation. I will talk about abstraction over CloudFormation, so AWS CDK, some best practices for CDK, and some issues also. And there will be a summary at the end. Okay, so infrastructure as a code. What is this concept? Basic idea is to use code instead of manual process to manage and provision deployed infrastructure. So in simple words, we use some kinds of configuration files to control the deployment process. And today, I will be talking about AWS ecosystem. And in the AWS ecosystem, CloudFormation service is used as infrastructure automation platform. So how CloudFormation works? As we can see on the slide, we simply have some YAML or JSON file with proper infrastructure configuration. It goes through CloudFormation, and we get our infrastructure set up on AWS. Simple as that. Does any other cloud providers have similar solution? Yes, of course. As far as I remember, in Azure it's a resource manager, and in GCP is a deployment manager, I think. Or maybe we can use something cloud agnostic. Also, yes, the most popular tool is probably Terraform. But I want to give you just overall view on the topic. Today we'll focus only on AWS ecosystem. So what are the advantages and what are advantages of this approach? We are handling multiple different services in a single place. We won't forget to delete unused resource anymore and generate additional costs by accident. It is also easy to reload or upload our architecture because CloudFormation uses dependency tree and detects any changes in configuration files. We can also move our deployment to a different environment, and it is quite easy to do so. So it seems like CloudFormation is perfect, right? It just helps a lot during cloud infrastructure development, especially when we don't have to do everything manually. But are there any challenges with this approach? Well, there are a few challenges, actually. When you think about this, CloudFormation still requires in-depth knowledge about the services, links between those services, network configurations, and so on. Another challenge is to learn the new way of patterns used in this configuration file. Also, bigger projects equal bigger and hard to read config files. So a single CloudFormation template may be extremely long, hard to review and understand. Okay, so how can we tackle these issues? Well, we can use AWS Cloud Development Kit. So this tool adds additional layer over CloudFormation. CDK project is active, updated daily, and also is open source. This is probably why there are a lot of people that are that actively contribute to this project, with over 2,500 forks, over 9,000 stars on GitHub, and more than 1,000 contributors actually. This tool is mainly written in TypeScript. However, there are also other supported languages, such as Python, JavaScript, Java, Go, and .NET Platform. And I already told you about languages. So what is the main difference between this approach and CloudFormation? We don't use any configuration. we use programming language to define the structure of our services in the cloud. So it already simplifies some things because we are using already familiar programming language. Now, instead of creating a single file config, like we used to with CloudFormation, with utilities of programming languages, we are able to split our logic into multiple files. This way, infrastructure will be more clear for other programmers and easier to debug for us. Another advantage that also applies to CloudFormation, but here it is even more relevant. We treat our architecture as a code. We split it into multiple files. That means that first we can use version control, for example, Git. And second, make code review pretty easy. Those two things really come in handy when we are dealing with infrastructure deployment with many different services. Okay, and another issue with CloudFormation was that parts of the configuration file are usually redundant. In CDK, we're using programming language, so why not use methods, classes that will add some additional layer over the cloud resources and help us parameterize those in a better way, so our code will be simpler without any redundancy. Okay, and the last thing to mention here is on the next slide. In general, CDK is quite easy to use. The main concept to grasp is stacks. What is stack exactly? Stack is a set of resources for a single application. But it is important to mention that one application can have multiple stacks. When I'm talking about application right here, I mean deployment of our infrastructure. In CDK nomenclature, this whole deployment is just called application. You can ask me right now, okay, but why can't we just pack everything into one stack? We already split our implementation into separate functions, classes, code is clear, well organized. Why do we even need multiple stacks? Well, I'll give you an answer in a minute, but for now, you have to trust me, it is useful. On the slide, you can see a simple example. We define backend stack that inherits from the stack class implemented in CDK, right here. We can also see that in deployment script, we append the stack to our application. We can name it, add description, or add additional tags that may be useful, for example, in billing information dashboard. And also, we can see that CDK handles multiple stacks. On the small diagram, we can see that we have, for example, database stack separated from the backend stack. Okay, now I will talk a little bit about best practices in CDK. If someone would like to read more about best practices, I recommend reading this link down below. There are some useful tips provided by Amazon. After developing application with CDK, I don't agree with everything they recommend, but in general, those are useful tips. Especially, I don't agree with some naming conventions and how services names should be created. But this is another topic, and I won't dive into that right now. Okay, I already told you about version control and code review. I think it's quite easy to understand why it might be beneficial to use in a project. So I won't repeat myself, and I will move to a second best practice. Now I have to mention about AWS solutions constructs. I like the picture on the slide. that I found on the internet because it sums up constructs pretty well. Constructs are basically patterns, or rather plugins, that are easy to use, implementations of popular resources used in AWS Cloud. So for example, we want to connect AWS Fargate to S3 bucket. Well, no problem. We have already implemented construct. It is interesting because we can build our application from these blocks that are already provided to us. Also, constructs are built based on best practices, and its base configuration can be easily extended. You can add maybe specific encryption for S3 bucket or some other security best practices that are must-have in your own project. And right here on this little picture in the presentation, we can see how the search looks like, how you can search the solutions constructs. Okay. So the next part of best practices, decisions and synthesis time, not deployment time. This means that it is possible to create changes during deployment process. And CDK introduces some mechanism to control deployment while it is running, but it isn't recommended. All conditions should be made directly in code with simple if statements. That way, during synthesis, CloudFormation config file is generated with proper settings. We should do it in synthesis time and not deployment time. Why? During synthesis time, we are using CDK, and during deployment, we are using CloudFormation because we already created this CloudFormation config, so we are using CloudFormation. And operations in CloudFormation are sometimes more limited than operations in CDK. Separating application into stacks. I already told you about stacks, but I haven't told you why this is important. Firstly, we have a better resources distribution and clearer project structure. But more importantly, we are doing it to separate stateful and stateless resources. I will give you an example. In the project where we used AWS CDK, we needed S3 buckets, ECR repositories, and RDS as our database storage. Those are stateful resources. We usually don't want to change those, and we don't want to change or delete data stored in those resources. On the other hand, we have stateless resources, like, for example, Lambda, assuming we don't have any underlying storage for it. We can change, modify, restart stack with stateless resources many times, and it won't affect our application storage whatsoever. This is why we should split the resources into multiple stacks for easier management. Also, create AWS identity and access management roles with AWS CDK. So CDK tracks connections between resources and automatically assigns proper roles, grants permissions, and so on. Of course, you can also handle it manually, but AWS CDK really simplifies this process, and it is recommended to use CDK this way. The next thing is abstraction layer over deployment. I already talked a little bit about that. It is also connected to the best practice number 1, so decision synthesis in time, not deployment time. We can parameterize input to deployment. That means that we can create separate configs, for example, for production deployment, staging deployment, with the same CDK code underneath. I will give you an example. We were using Bastion in our staging environment. This was simple EC2 instance. We used it for debugging and to access our database. And also we accessed our backend container with it because, well, all our resources were closed in private subnet. So it was really useful for debugging and staging environment. That was only used by developers, but it is really bad idea to use it in a production environment because it might be potential security vulnerability. So in our production configuration for deployment, we simply set this resource to false, and our deployment ignored creating bastion step automatically. Okay, and the last thing that is a universal best practice is monitor results. Create logs, metrics, alarms, dashboards, basically everything that AWS offers to control deployed stack. With CDK, it's pretty straightforward to enable logs and metrics for the services that you want to deploy. Well, and it's really helpful during debugging application. And now a little bit about issues. Well, everything seems so perfect, but how it really looks like. So tool is still during active development, and there are bugs and issues, especially when you want to use services that aren't popular. You might encounter some difficulties. As you can see right now, there are 1,700 issues open. Other thing to consider when using CDK in general, it is well documented. However, sometimes you will find examples that don't work, or parameters you find an example that parameters doesn't exist or don't have any description. Well, that means that eventually you will find something that will force you to go through implementation to find out what it does and not to rely only on documentation. And the last thing, some resources in CDK doesn't implement all features of given resource. This means that sometimes you have to supplement your code with additional bash scripts that will handle some operations through, for example, AWS CLI. For example, in our case, we weren't able to create RDS PostgreSQL instance with multiple databases. You can only create single database inside PostgreSQL instance. For a workaround, we could have created custom resource Lambda that would create additional database, but it's not the point. You can find this open issue among many others on CDK GitHub page. In general, AWS CDK works great if you want to set up standard application with, for example, RDS, VPC, maybe ECS with front-end and back-end containers. But the more you need to change, maybe add additional resources, connections, configurations, well, CDK can become not that effortless. Okay, and now let me summarize presentation. From my perspective, I must admit that in our project, CDK was really useful. Although we had some issues with it, CDK made our code cleaner. Source control with code reviews allowed us to avoid many errors. And automation that goes with it, with the tool, helped us a lot. Simple example, we didn't have access with proper permissions to our client AWS till the very end of the project. And when we got the access, we are able to deploy whole architecture really fast in entirely different region on different AWS account with different settings without any major issues. And that is a good argument based on real life scenario to use infrastructure as a code concept in general. That's everything that I prepared for today. Thank you. And I encourage you to try AWS Cloud Development Kit yourself.